All right, so the question, this is May 2018. Question number 9. The question reads, the diagram below, not drawn to scale, shows the relative position of 3 reservoirs, B, F, and Q, all on level ground. The distance, BF is 32 kilometers, FG is 55 kilometers, angle BFG is 103 degrees, and F is on a bearing of 42 degrees from B. We're to determine the bearing of B from F. We're to determine the bearing of B from F. So wherever I'm taking a bearing from, I'm going to go to that point and draw my north south line. So it's the bearing of B from F. All right. One button. All right, let's draw it down. This is my north direction. My north, south, east, west line. Of course, bearing is measured clockwise from north. Now, if it is the bearing of B from F, you're going to start at F, come around to the line that connects B and F. All right. Now, so we need this entire angle. Starting from north, coming around to the line that connects B and F. The first half we know is 180 degrees. The angle between north and south is 180 degrees. What we don't know is this piece, and I'm going to call it alpha. So I'm going to say alpha is equal to 42 degrees. And the reason for that is that they are alternate angles. They're alternate angles. So the angle alpha is equal to 42 degrees. They're alternate angles, which are Z angles. Everybody should be able to see that. All right. Now, it means, therefore, that the bearing of B from F, that bearing would be equal to 180 plus 42 would be equal to 222 degrees. The bearing of B from F is 222 degrees. All right, so that's the first thing. Let's turn the page and see what they want next. They wanted to calculate the distance BG, giving your answer to 1 decimal place. All right, so we want the distance BG. So let's call this X. All right, so first of all, BFG is a non-right angle triangle. I know the length of 2 sides and the angle between them. Now, if I have a non-right angle triangle, and I know the length of 2 sides and the inclusive angle, and I wish to find the length of the 3rd side, it is a condition for applying the cosine rule. All right, so the 2 sides are 32 and 55 degrees, sorry, 55 kilometers, and the inclusive angle is 103 degrees. All right, so let's go to the next page and work this out. So I'm going to apply cosine rule, so let's write that. Now, in the cosine rule formula, A is the side opposite the inclusive angle. So A is what we want to find. This is X. B and C are the other 2 sides, which are 32 square plus 55 square minus 2 times 32 times 55 times the cosine of the angle between them, which is 103 degrees. All right. Now, if we wanted to, let's just work it down a little, even though you could have just put the entire thing in the calculator and press equal. So 32 square is 1024. 55 squared is 3025 minus 2 times 32 times 55, which is 3520. And this is cosine 103 degrees. All right, just working down a little bit more. So this is 4049 minus 3520, the cosine of 103 degrees. Now, the opposite of square is square root. So x will be the square root of that. So we have the square root of 4049 minus 3520, the cosine of 103 degrees. All right, and x, which is bg, is equal to 69.6 kilometers. So we're to write the answer to one decimal place. It's 59.6 kilometers. So next we're asked to calculate to the nearest degree the bearing of G from B. So let's go to our diagram and identify that angle. The bearing of B from G. So wherever you're taking the bearing from, you're going to go there and draw your north, south, east, west line. It is the bearing of B from G.
Sir.
Uh-huh.
So the bearing of G from B.
Sorry?
So the bearing of G from B.
It's G from B. Okay. All right, thank you for that correction. So it's the bearing of G from B. All right, so what I need is this angle here. All right. So this piece I would already know. Well, I don't have to go that route. I don't have to talk about 90 degrees. I already know a piece of it. I know that the top piece is 42 degrees. What I don't know is this bottom piece here. I'm going to call it alpha. I did alpha already, so let's call it theta. The bottom piece here is called theta. That's all we have to find. Now, I said this to you before, I'm going to say it again. After you use cosine rule on a triangle, and you want to find out something more about the triangle, you must use the sine rule. So that the angle theta is what we want to find. So it's going to be, for the sine rule, it's going to be the sine of theta over the side opposite to theta, which is 55, is equal to the sine of 103 degrees over the side opposite to it, which is 60, how much? 69.6. All right, and that should give us the answer. All right, so after we apply the cosine rule to a triangle, we must apply the sine rule. So it's going to be the sine of theta, the angle we want to find, over 55. The length of the side that is opposite to the angle is equal to the sine of 103 degrees, which is the other angle, over the side opposite to that, which is 69.6. Do my half cross multiply and get this up here. So I'm going to have sine theta is equal to 55 sine 103 divide by 69.6 degrees. Now, I can put this in my calculator and write my answer to 3 decimal places. So it's 55 sine 103 divide by 69.6. And the answer there is 0.0 0.770 to 3 decimal place. 0.770 to 3 decimal places. If I know the sine of an angle, to find the angle, I must use sine inverse. So theta is equal to sine inverse 0.77 and theta here is equal to 50 degrees. It's actually 50.4, but I'm going to drop the 0.4. And so the bearing of G from B, that bearing will be equal to 42 degrees plus 50 degrees. The answer is 92 degrees. All right, sorry. With bearing, you always write it in 3 digits. So if it's only 2, you put a 0 before it. The bearing of G from B is 092 degrees. All right. And that is not the end of the question. I thought that would have been. All right. So I'm going to end there though, and then we'll come back. Then I'm going to